Welcome back. We're going to continue our discussion on gas laws. And previously, we looked at the ideal gas law. From now, we're going to look at a bunch of laws where we only compare two variables. Okay, we're going to keep the other two constant. So when you're given three variables in a problem, you use ideal gas law. For instance, in all of the previous problems we looked at, either pressure, volume, temperature, or pressure, temperature in grams, or pressure, temperature, moles, three things were given. But from now, only two variables will be given, and we try to understand the relationship. Now, all of these laws, if actually taken the time to derive, comes from the ideal gas law. So if PV equals nRT, if you keep two of the variables constant, well, keep in mind, R is always constant. So in Boyle's law, the number of moles in T are constant as well. So if you only change these two under two different conditions, then you end up with this. Okay. So this is one law where the two variables are inversely proportional. That is, if you increase pressure, you decrease volume. You decrease volume, you increase pressure. Right? Think of your old school air pump that you used to have to inflate the tires in your bicycle. Every time you go down, the piston goes down, you're increasing the pressure and you're compressing the gas into a smaller volume, which then gets out of a nozzle through the pipe into your tires. Every time you pull the piston back up, the pressure is reduced, the volume goes up, right? The same convention here. So I've just shown it with two different pistons. On the left, you have the piston at the normal volume, and you put more pressure by adding more mass to your piston. You go from 1 kg to 2 kg. Or you could think of some other ways to push the piston down. The volume went down, the pressure went up, right? You see the pressure was at 1, volume was at 1, and pressure was 2, volume was half. So here's a problem. So if 22.4 liter of, so when it's just two variables, as long as it's not temperature in the equation, you do not have to convert, okay? So this equation does not have temperature, and obviously temperature is constant. So V1 is 22.4 liters, right? So this is the volume. It doesn't matter which one you are saying, V1 or V2, but generally, the starting is V1, ending is V2. So if 22.4 liter at this pressure, so that's P1 is 748 millimeters of mercury, is compressed to the new volume. So this is V2, because it's relative, right? But we have to keep, it doesn't matter which one you assign V1 or V2, but whatever you assign V1, you must assign the corresponding value with the P1. Otherwise, if you mix and match, you're going to have a problem. But generally speaking, the first set of condition is V1 and P1. The second condition, so V2 is what we need to find. P2 is your new pressure, which is 725 millimeters of mercury. Like I said, when it's just pressure and volume or anything else that doesn't involve temperature, you do not have to convert it to Kelvin. And unless you're an ideal gas law, then everything must be converted. So P1 is 748, and P2 is 725, and V2 is what we need to find, and V1 is 22.5 liters. Solve that, you do the math. So 748 over 725 times 22.5, 23.21 liters. So Boyle's law is when you are dealing with pressure and volume as the two variable, and it makes sense. We reduced the pressure, so volume should go up, and yes, it did went up from 22.5 to 23.21. And here is the practice problem for you to work. and this will be part of your my thoughts. All right, so stay tuned for the next law.